Problem 3 is to sketch each of the region and find the area of the enclosed region. So part A, y is 2x minus x squared and y is negative 3. So first you have to be able to draw the graph. So quadratic equation you find when y equals 0, right? When x equals 0, y is 0. When x is 2, y is 0. And because it's negative, so it should be something like this. Okay, when x equals 1, it's maximum. Right? Y equals 3, it's just when y equals 3, this. Right? So the area is this. Okay, then how do we represent this area? First, you have to figure out these two boundary points' x value. Right? So what you have to do is just 2x minus x squared equals negative 3. So you figure out that this point is negative 1 and this point is positive 3. Then the integration is just from negative 1 to positive 3. This upper minus lower, right? This upper curve minus the lower curve. So it's 2x minus x squared minus the lower curve negative 3 dx. So the integration is negative 1 over 3x cubed plus x squared plus 3x from negative 1 to 3. Okay. Then the result is 32 over 3. Okay. Part B, y is x squared minus 2x and y is x. The same way, right, to draw the quadratic equation, you find out when y equals 0, and because x squared is positive, so it's like this, and y equals x is a straight line like this. Right, first you have to figure out what is this point, so you have to equate those two equations. Right, which means your x is 0 or 3. So this point is 3, this point is 0. Then what you want is the area under the curve. Right, so it's starting from here, and here is from 0 to 3. Right, the higher curve minus the lower curve. Higher curve is x minus the lower curve is x squared minus 2x. Okay. So the answer is 9 over 2. Alright, part C and part D are a little bit different. So part C, now x is y squared and x is y plus 2. So what is x is y squared? Y is x squared is like this, right? This is y is x squared. Then what is x equals y squared? So you can see, for example, when x is 1, y is positive or negative 1. Right? When x is 1, y is positive or negative 1. When x is 0, y is 0, so using your imagination. This is your x equals y squared. Right? And it's not even a function because for each x you have 2y. But it doesn't matter. Right? It's a curve. Then x equals y plus 2. Then when x is 0, y is 2. When x is when x is 0, y is negative 2, right? When x is 2, y is 0. So you connect this 2. So you have this region. Right. For this region, if you integrate by x, it's very hard, so we can integrate by y. Right? You can see for each y, for example, for this y, right? This length is what we care. We want to integrate this length. Right? And what is this length? This length is this. It's just this part minus this part. Right? It's a bigger part minus a smaller part. What is a bigger part? It's given by this straight line. So it's you given y, your x is y plus 2. Okay, because this part is just y plus 2. And this part you're given y, your x is y plus 2. And this part you given y, your x is y squared. So the length of this blue is y plus 2 minus y squared. Right, and you do this for every y from here, right, from here to here. Okay, because if you equate these two equations, y squared equals y plus 2, you solve it, it's going to be y equals 2 or y equals negative 1. Alright, so for y from negative 1 to 2, for each y, the length of x is this much. Right, so you just integrate this, you will get the area, the red area. So this part is negative 1 over 3y cubed plus half y squared plus 2y from negative 1 to 2. Okay. I'll just do it. It's 9 over 2. Okay. So part D, x is y cubed minus y squared, x is 2y. So this part, it's hard to draw the graph. You can use your calculator to help you. It will be something like this. Okay, this is your x equals y cubed minus y squared. Okay, then the straight line is this. So as you can see, there are two parts, right? There are two parts. First, again, you have to figure out what are the intersections. So y cubed minus y squared equals negative 2y, right, which is y equals 0. So y equals 0 or -2 or sorry, not -2, should be -1, right, or 2. So this point is 2, this point of course it's 1, sorry, it's 0, this point is -1. So what we want is these two regions. You can see from 0 to 2, from 0 to 2, this part is on your right, right? The straight line is on your right, the curve is on your left. So you should, to get the length of this, for each y, to get this length, you have to use the right side x value minus the left side x value. So the right side x value is 2y minus the left side x value, which is this. Okay. So plus, then from -1 to 2, sorry, from -1 to 0, this part, right, you can see this length is the right side minus the left side. Now the right side is a curve, the left side is the straight line. Right, so the right side is a curve, the left side is a straight line. Okay, then you do the calculation by yourself. It's 5/12. Okay, again, this part you are not expected to draw this down. Okay, you can use your calculator to help you with this part. But for the analysis, it's always the right side x value minus the left side x value. It's just like, right, previously when you calculate y, it's always a higher curve minus a lower curve.